Hi team, here we are. We're going to take a look at the derivative of a quotient rule. Now following the derivative of a product rule, this is, instead of taking the derivative of two functions that are being multiplied, it's taking the derivative of two functions that are being divided. Hence the word quotient. That's what that means, the answer to a division statement. Okay, so first thing that we need to know, we need to be very, very clear on, is that the derivative of a quotient is not, shall not, never will be equal to the derivative of the top divided by the derivative of the bottom. It's just not that simple. I'm sorry, it doesn't work that way. It is, however, given by this statement, which is a little bit more difficult than the product rule. But I promise you, if you can say it, you can do it. Now watch me. I'm going to call this the top function. I'm going to call this the bottom function. I'm going to lose the word function. I'm going to call this the top. I'm going to call this the bottom. You ready? The derivative of a quotient is the derivative of the top times the bottom. Subtract the derivative of the bottom times the top, all divided by the bottom squared. Isn't that cool? Remind you of the product rule? It should. But you got to keep the order important because it's a subtraction. So, once again, top and bottom. The derivative of the quotient is the derivative of the top times the bottom. Subtract the derivative of the bottom function times the top function, all over the bottom function squared. And as long as the bottom function doesn't equal 0, we have to follow with the same restrictions that we would with a normal rational expression. Here's Leibniz notation. This says taking the derivative of u divided by v. So this says take the derivative of u, then multiply it by v. Subtract the derivative of v and multiply it by the function u, all over v squared. And again, it's the same top and bottom routine. So let's get busy. Let's take a look at this question. I'm wondering where I put my pencil. Hold on just a second. Oh, I don't like that marker. That marker's not a fun marker. Here we go. Okay, so this is the top. This is the bottom. It won't hurt you to write this out once in a while. So the derivative of h of x is going to be the derivative of the top times the bottom. Subtract derivative of the bottom times the top, all over the bottom squared. Do it and you can say it and you can do it. Okay, so let's see what we got here. So the derivative of the top, the derivative of 3x minus 5 is 3 times the bottom. That was simple. Subtract the derivative of the bottom. Well, that's 2x times the top. Well, that's kind of cool. All over the bottom squared. That's the calculus. All the calculus is done. I'll give you 2 marks for that. The calculus is over. Everything else is algebra. So, h prime of x, expand, 3x squared plus 15 minus 6x squared plus 10x, all over top of, don't expand the bottom, because if we can divide, if we can factor, we're going to. If we can reduce, we're going to. We're going to leave that in factored form. So h prime of x, we're going to take a look at 3 squared minus 6 squared is negative 3x squared plus 10x and plus 15 all over top of x squared plus 5 squared. Now again, we're not going to expand the bottom. If anything, we're going to try to factor the top. So we're looking for 2 numbers that multiply to give negative 3 times 15, which is negative 45. So I reach over and I grab a scrap piece of paper and I say, okay, it's got to multiply to be negative 45. It's got to add to give 10. What are the factors of 45 that go evenly? 1 and 45, 2 doesn't go evenly. 3 and 15, 4 doesn't go evenly. 5 and 9, 6 doesn't go evenly. 7 doesn't go evenly. 8 doesn't go evenly. 9 and 5. So if it factors, it's going to be one of these. Which one of these will go together to give 10? None of them. That means that that top trinomial does not factor. I'm not sitting there worried about it. I'm not trying to factor it. I've done something that tells me it can't factor. These are the only numbers that will multiply to give 45, and they're the only numbers that can be added to give 10, and none of them work. So it does not factor, and you are done. If it did factor, then we'd only be interested if it reduced out one of these x squared plus 5. But then we would have to factor to know that. But that's why we're factoring. We're just not randomly factoring everything. And that's why we're not randomly expanding this. There's a reason for this. If we can factor that and reduce this and make this smaller, that's wonderful. If not, then we leave it alone. Implied in all of this, and something that you won't necessarily be responsible for doing, but we should be aware of it, that there is a restriction here. There is a restriction that x squared plus 5 cannot equal 0, which means that x squared cannot equal negative 5, which means x cannot equal plus or minus the square root of negative 5, which is a complex number. And as long as we're dealing with the real numbers, which is what we normally are in calculus, normally every single answer we're dealing with will be an element of the reals. There will come a time when we do deal with complex roots. And again, we're not responsible for this, but I want you to be aware that we can't divide by 0. So we do have a restricted domain. All right, let's go on to the next example. So here we go. We have y equals 2x over x squared plus 1. This is definitely a quotient question. So, and it wants me to find the equation of the tangent line. Same question over and over again. So if I'm going to work with the equation of a tangent line, I'm going to have to work with, that's going to give me the equation of a line. And what I need is I need a slope and I need a point. Okay, so let's start off finding our slope. So the slope of the tangent line is going to equal, in general, the derivative of y. So the derivative of the top, which is 2, times the bottom, subtract the derivative of the bottom times the top, all over the bottom squared. Now, I can expand this, or I can notice that I want the slope of the tangent at a particular value of x. It depends what you think is easiest at this point. Y prime of 3 is going to equal 2, 10, minus 6 times 6 over top of 9, 10 squared. So we're looking at 20 minus 36. That was almost a big mistake. 20 minus 36 is going to be negative 16 over 100. So divide that by 2, it's going to be 8 over 50. Divide that by 2, it's going to be 4 over 25. And I think that's where I'm going to have to stop. Okay, so I divide the top by 4, divided by the bottom by 4, and this is giving me a slope of the tangent when x equals 3 of this value. That's great. Now I need a point of tangency. That's the point on the curve where the tangent's just going to touch it. So the point of tangency is going to be given by 3 comma y of 3. So we have to figure out what y of 3 is, and it plugs back into the original. So it's going to be 6 over 10. Which will reduce to 3 over 5. So we've got some fractions happening here. Well, let's go up and put them into our equation. So our values here are going to be y minus y1. So that's x, that's y. So it's y minus 3 over 5 equals negative 4 over 25 is my slope, x minus 3. Okay, now that's pretty ugly. And what we did here, just so that you know, we plugged in that value and we plugged in that value. So that's pretty ugly. I want to clear the fractions. So if I multiply everything by 5, I'm still going to have a denominator of 5 here. But if I multiply everything by 25, it's going to get rid of this denominator 25, and it's going to reduce with this denominator of 5. So multiplying everything by 25 will be 25y. Now 25 divided by 5 is 5, so it's going to be 15, 5 times the 3. The 25 will reduce, and you don't multiply the 25 in here because this is one term being multiplied by another term. So we multiplied our 25 by this term. It doesn't go inside this term. So now it's going to be 25y minus 15 equals negative 4x plus 12. The 4x needs to be positive. The 25y is positive. The negative 15, negative 12 will be negative 27 equals 0. And that is the equation of the tangent to this line when x equals 3. And why don't you go and check that? Why don't you go and check on Desmos? Why don't you learn how to put in an equation that looks like this, take a look over where x equals 3, make the slope of the tangent roughly by looking at it, and see what you come up with. Okay, you can even have this inputted into the Desmos, and it will graph it on your equation. You may have to make it in terms of y equals, but you could graph both and see where they intersect, and you can check that that works. Okay, guys, that's it for the quotient rule. And do your work, practice this up, and we'll see you in class.